This is Wilfried, the PCB designer again. The design is fully verified by Rory for SI, PI and EMC behavior. Before we want to prepare the design for manufacturing, my colleague Maxim, the multi-physics simulation engineer, and I need to check the board for thermal and manufacturing issues. The advantage of DFF validation is that it not only identifies where my PCB design has direct violation of manufacturing capabilities, it also shows where I need to expect low yield or field failures. Especially field failures could cause very high costs in the maintenance phase of the product. Imagine this board is a control unit for a windmill in an offshore farm. The costs for repairing just one device could easily exceed the development cost of such a product. For this reason, it is important that I'm using a DFF software supporting all design technologies, from FR4 to Flex, with more than 900 DFM checks. Each check represents a problem or an issue not optimized for manufacturing. Before I'm going to check the full board automatically, I want to check which rule sets are available. For the full DFF, we want to run rules out of all categories, like edge, solder and mechanical check, based on different factors like layer count and copper height or weight. Valor NPI defines which parameters needs to be used. This helps me a lot and avoids the need to prepare different rule files for each technology. If we test our design, we see that the design has the category high dense. Valor NPI goes beyond these typical DFM checks and also compares the design netlist against the manufacturing data. Additional to that, it even validates the manufacturing BOM matches the design by comparing all components in the approved vendor list against the design components. DFM validation further categorizes and prioritizes the design change requirements, so that you may easily resolve the most critical issues first. The weight assigned to each check is definable, enabling you to decide how the result should be prioritized. Reporting issues can be done by using a share list or MRA report based on HTML, Excel or XML files. Similar to a share list, a user can control which items are added to the report. With this, we are able to generate different types of reports for DFF review or for the PCB designer. In our case, we want to generate a report with all slivers. This report should act as a list of items fixed in the next revision of this design. For now, I can live with all issues and I can generate the final set of manufacturing data.